Welcome back to Diamond's Concepts. Today, what we're looking at is a variation question. All right, so we'll be looking at variation right now. Let's get into it. The table below shows the corresponding values of the variables x and y. So we're looking at the variables x and y, where y varies directly as the square of x. So this is very important. So y varies directly as the square of x. Question wants us to calculate the values of a and b. Definitely understanding the table, a is, as you can see here, it's an x value, and b is a y value. So basically, we're going to be finding x and y's. We label the spots a and b depending on what we're doing. So let's see first. When we're doing a variation question, what we want to do firstly is to write down the formula or an equation that shows how they are related. So it says y varies. So we're going to start off with y is equal to kx. So you might be wondering, where do I get that k from? The k refers to the constant of variation. So variation can't be worked out without a constant. So there is a constant of variation. I'm calling that k. So in this context, when we're doing the direct variation, this is how the formula is set up all the time. The first variable to the left, which is directly, which is equal to kx, which is this other thing here. It says the square of x, so you have to make sure you put on that square there. So it says y is equal to kx squared, right? So that is the equation that is linking x and y. Now, in order to solve these problems, what we want to do is find the value for k first. So we definitely need to find k first because it is the constant. We need it. So we can find k by using a situation that occurred like this. When x was 2, y was 16. So this occurred already. So we could substitute these values in this system. So let us do that. Y is equal to kx squared. Y is 16, so I could say 16 is equal to k times x, which is 2 squared. Let's continue. 16 is equal to k times 4. The objective is to find k. So I'm going to divide both sides by 4. 4 is equal to k, which is the constant of variation. So now that I have a value for k, which is constant, while the other variables are changing, for example, the x variable was 2 at some point, it became 5 at some point. The y variable is 16, it becomes 64 at some point. So they are changing. The good thing about the constant, it's not changing. So then we could find a value for a. A is an x value that we don't know. That is okay. But at the same time, when a is an x value, if you look, we have the y value for it, which is 64. So y was 64, and the k will remain constant at 4. So there it is that we have these. So let us substitute in the formula, because this same formula is the formula that controls this question. So it says y is equal to kx squared. Y is 64. 64 is equal to k, which is 4 times x squared. Now, as you could see, we're going to divide both sides by 4. We're going to divide both sides by 4 in order to get x squared. So 16 is equal to x squared. Now, in order to find that, then we're going to take the square root of both sides. So we're looking at 4 is equal to x. So then we're saying that when y is equal to 64, x is equal to 4. That's what we're saying right there. When y is 64, x is equal to 4. All right. All right. So let's go for B. All right. Let's go for B. Now, B, so let's bar off this. Like, give myself a little space. Let's not just bar off this right here. Now, remember, B is a y value that we don't know yet, but K is the constant, which is 4, and X, as you could see, is 5. So you could see what's going on with B and the 5. So X is 5 right there. We're going to substitute this in the formula. The formula says y is equal to kx squared. Y, which is B, is equal to k, which is 4 times x squared, which is 5 squared. So we're talking about 4 times 25, and B is 100 right there. So B is 100. So we're seeing here that when x is 5, then B is, we get B there to be 100. All right. Remember over here, this was A as well. So 4, my bad, is equal to A. A is our next value still. So the A here was 4. All right, I didn't write it. And B, as you can see, it's a y value and it's 100. So there we go. All right, let's go for another. Now, this question reads that the table below shows corresponding values of the variables x and y, where y varies inversely. So this time, y varies inversely. No, y is inversely proportional to x. Let me read it over. The table below shows the corresponding values of the variables x and y, where y is inversely proportional to x. Now, inverse proportion. So y is inversely proportional. So we start off by saying y is equal to k over x. When we have an inverse proportion, the second variable actually acts as a denominator. And I could just quickly show you why. Y is equal to k times the inverse of the other. And the inverse of x is 1 over x because it is inversely proportional to x. Hence, you're going to see this coming out. But if we should simplify this, you could see why it is that I would have given it as this, because definitely this x will function as a denominator. So if you simplify this, you're getting y is equal to k on top over x. And that is why I start off with this as the formula. So definitely we could just take a quick look at that. And then we travel, okay? So there it is. All right, so we could take off back this piece right here and then try to solve some problems. Again, the situation occurs when x was 2, y was 6. So we could write down that when x is equal to 2, y was equal to 6. K, the constant, we don't know. Now, we are going to substitute 2 and 6 where x and y is to find k. So let us go. Y is 6. So y, which is 6, is equal to k over 2. What we're going to do is to multiply both sides by 2 in order to get the k by itself. So k is equal to 12. So the constant of variation is 12. All right, so if I know that the constant of variation is 12, then I can now do a number of things. For example, let us just split this up. We're going to find the value of a, which linked to 3. So let's look. X is an a value that we don't know. K is 12 and y is 3. So we're going to substitute y. We're going to substitute in this form, y is equal to k over x. Y is 3, which is equal to k, which is 12 over x, which is a value. All right, so I could put a there for now. As you could see, we could quickly employ cross multiplication. So a times 3 is equal to 1 times 12. All right, so I could put that at the side here. So 3 times a is equal to 1 times 12. divide both sides by 3. A is equal to 4. So right now, A is equal to 4. So you could see that when Y is 3, A is equal to 4. All right, let's go for the B value right here. So remember that Y is equal to K over X. K is the constant at 12. This time we want to find a B value, which is a Y. So the B value is a Y value that we don't know yet. Definitely the X value in that context is 4. So then in substituting, B is for the Y value, so I'm putting the B where the Y is equal to 12 over 4, which is 3. So B is 3 when X is 4, right? B is 3 when X is 4. And you could see when X is 4, B is 3. All right. All right. So there it is. We have found those values. So just say, guess what? Thank you for watching and see you next time. Bye-bye.